Hello, guys and girls. The program you are about to hear will be both fun and educational, but it is not a substitute for medical advice. Although we are doctors, we are not your doctors. Hello, and welcome to Travel Medicine. As always, I'm your friendly neighborhood internal medicine doc, Dr. J.
Hey all, this is Dr. Santhosh, pediatric infectious disease doc and a researcher.
And, well, we've kicked off our new season, so I don't know. I don't really have a lot of gossip or to catch up on or tea to spill. I'm sorry.
Well, yeah, there hasn't been a lots of goings on and such. It's like starting a brand new chapter. Like all the other stuff is behind us, and we're gonna put our behind in our past.
It's about the little things. Like, for example, today I
Yeah.
learned that humans are the only animals uniquely suited for throwing. And
Yes. Uh huh.
also, you remember the song Who Let the Dogs Out by the Baha Men?
Yeah, absolutely. I don't know any of the other lyrics of like the chorus of the verse besides "Who
No,
Let the Dogs Out."
no, I listened to a whole show about that, and it just struck me that they were named that because they were from the Bahamas. They were Bahaman.
Baha
Baha Men.
Men, yeah, yeah,
And let's round out the hat trick of embarrassment.
yeah.
What is a DJ's favorite kind of sauce?
A DJ's kind of favorite. Let's see. Mix. No. Tomato. Tomato. Tornado. No, I don't know. What is it?
Marinara.
Oh God! You got me with a stupid one. Whoa!
So it's
Ay.
our first alternate week, and
Mm,
we're not going to ramp up to the full craziness yet. That would spoil the whole season. So we're going to do this incrementally.
yeah.
And
Fetch my Kermit arms before I sit down here in front of the microphone.
okay, Kermit arms ready and up.
Kermit. Yeah.
It's time for everybody's favorite segment, Journal Club.
Woo!
Yay!
You're not sure what the alternate week is? Um,
It's whatever
don't.
we say it is.
Yeah.
So in this one, all the stories this week are going to deal with incremental gains. We're making progress. Not a
Yeah.
lot, but
Yeah.
progress.
Yeah. And a lot of the time when we're talking about incremental gains, we're talking about diseases that we have been struggling with diagnosing or treating for a very long time. Sometimes because we can't get to the cause, sometimes because we don't know the cause. But science is not these massive breakthroughs. It's these little incremental steps that get us closer and closer.
So how do you like your blood cells, Santosh? Normal,
Hmm.
sickled, or extra crispy?
Ooh, I mean, normal. You're talking about my red blood cells. They should be nice and squishy.
There are people who don't have those, and
Yeah.
they have sickle cell disease or sickle cell trait,
Yes.
where
Hmm.
instead of looking like a tiny little frisbee or UFO, your blood looks like, well, a sickle or a half moon.
Yeah, and this tends to happen when there's a low oxygen environment. So, if they're exercising and, the specific or the partial pressure of oxygen in your bloodstream gets a little bit low, or if you go to any kind of high altitude, anything like this. Josh, believe it or not, the sickle cell trait was evolved because you get resistance to malaria, which is pretty darn cool. But if you have not just the trait, but both of your hemoglobin genes, your beta globin genes are sickle, then it's a very early deadly disease.
Now, one of the things that can help prevent it is elevated fetal hemoglobin. So this hemoglobin is better at holding on to oxygen tightly
Yeah.
and compensating so it doesn't get sickled in low oxygen environments. And that's why this is important because we're going to be talking about fetal hemoglobin. Just a baby hemoglobin.
Yeah, it is. And kind of the cool thing is that fetal hemoglobin is turned on as, you go from being like a bundle of cells into a fetus, embryo and then a fetus, and you start making different types of cells, right? Some of them being your erythroid, so called red blood cell precursors. And yeah, first you start getting fetal hemoglobin because you're not breathing, right? You're not getting oxygen from your lungs. You're getting it from mama through the placenta and your umbilical cord. So the way that you exchange oxygen and carbon dioxide in your tissues is very different. So the fetal hemoglobin comes around and then you're born. And then there's this cool regulatory, like gene regulatory chain that happens. And it shifts over a little bit of time to adult hemoglobin so that you can breathe air rather than having to need a umbilical cord kind of a thing. But here's the weird part, Josh. The fetal hemoglobin, right, works pretty darn well actually even when we're adults.
It's like stealing blood cells from a baby. Only that
Yeah.
baby is you.
Yeah. It's we're actually in a
So,
small way we're de-aging you. Yeah.
so researchers have begun over the last several years using CRISPR-Cas9
Hmm.
to edit genes in stem cells, in this case from three sickle cell disease patients, to increase the production of fetal hemoglobin, who then got their own edited cells reinfused. And
Okay.
all three had reduced symptoms and clinical improvements. But three people is not enough to really blow your own horn on this. So let's
Okay.
talk a little bit about the various trials that have been going on since 2020. Uh,
Okay.
Nothing much happened that year, so a lot of research was done.
Yeah. There was, we didn't have to completely shunt away our efforts to,
It's like some of these
complete.
scientists never left the lab.
Yeah, sure.
So
Okay.
the trial CTX001
Yes.
was a trial for treating sickle cell disease to restore the expression of fetal hemoglobin. So they did this, of course, on the three people we talked about,
Hmm.
and all of them have actually been showing a lot of progress. So at the American Society of Hematology meeting in 2020, the data showed that 10 patients had three with sickle cell and seven with beta thalassemia had all managed to achieve essentially remission of sickle cell disease.
It's so cool. Yeah. So, you're not doing what we'd like to do, which is actually to get rid of that sickling beta globulin gene and actually replace it with a non-sickling, aka normal beta globulin gene. But that's, you got to reprogram the genes and do a
So
stem cell
that
transplant and
was
all this.
so
But
that was the first one,
yeah,
CTX1, and at the follow up in 2021,
yeah,
another 22 patients showed the same improvement.
yeah.
Next came the Edit 301 Ruby CRISPR trial, which sounds like a burger. The Ruby CRISPR.
It sounds like you're calling a football play. Edit CT1 Ruby CRISPR go.
So that again, it edits a promoter region. So rather than editing the hemoglobin itself, it upregulates it,
Yep. Mm-hmm.
and it is undergoing trials since 2022. So it's in recruitment, end of recruitment. Now, the newest one is called GPH 101, and they are trying to restore the expression of adult hemoglobin rather than replacing it with fetal hemoglobin. And that's a
Oh, okay.
autologous CD34 transplant.
Yeah, those are your stem cells. We actually, Josh, we have what we call hematopoietic stem cells. Those aren't like, stem cells that can write beautiful verse in blood, but they, sorry, but they are the progenitors of all of your blood cells that actually, in small amounts, circulate in your bloodstream and live in your bone marrow. You can harvest those, edit those, and then give it back to the person, so called autologous. And if it works, then those stem cells start churning out red blood cells with normal hemoglobin rather than with sickle cell.
So all of these are basically being used to slowly induce a remission in sickle cell, which is great because it can be an incredibly painful disease.
And
Uh,
deadly, yes.
but there is going to be an equity of access issue, which we'll have to watch for. Who can afford to have their genes edited,
Mm-hmm.
and where
Yeah.
and where are these clinics going to set up shop? And as long as we're talking about dubious successes,
It's a little bit, yeah, yeah. Basically, great idea. How do we scale it up and bring it to everybody who needs it? Yeah. So what other dubious successes are you going to give us?
oh, just a treatment for Alzheimer's, which it's been about 5, 6 years, right? It's time for another one of those to
Sure.
show up.
Yeah. Yeah. And I'm glad that we were talking about this a little bit because there was huge controversies on some of the first Alzheimer's drugs that made it through. Horribly expensive and only marginally effective. So I guess this one was different, huh, Josh?
Yeah, so we're going to be talking about leqembi,
Okay.
Leqembi, approved in January of this year under the
Hmm.
accelerated approval pathway, which
Yeah.
is, when there's a serious condition with an unmet need, you can get this accelerated approval.
Yes.
So, clinical trials evaluating leqembi enrolled people with the most common form of Alzheimer's disease in people 65 and older. It was randomized, double blind, placebo controlled, and parallel group that took almost 2,000 people in total.
Yeah. The antibody that we're using, a monoclonal antibody called lecanemab, is going to bind to that horrible amyloid plaque, right, Josh? The one that causes all the disruption in the brain. And the safety had been well studied. So now, in order to really show whether or not it works, you need lots and lots of people in both of those arms to show that there's a genuine difference between the people who get the drug and those who get the placebo.
The first one problem, and we're not really going to go into this one, we'll just take it, I guess, as a given, is that we still don't entirely understand the relationship between plaques and the disease process in Alzheimer's.
Yeah, yeah. We're pretty sure now, and this took a lot of argument and everything like that, that the plaques are kind of it's a symptom of the Alzheimer's dementia and everything. So it's a hallmark of the disease, but it's actually not the underlying cause. So there was already argument about this because they said, why are you going after the amyloid plaques? That's not actually the cause of the disease. But this drug was in development over a long period of time before we had this, scientific argument, so to speak. And we wanted to check the efficacy.
So they took patients with only a mild cognitive impairment or mild dementia stage and
Mhm.
confirmed amyloids in the brain, and they got either placebo or leqembi every 2 weeks, and they did show a reduction of decline from baseline to 18 months, which was the primary endpoint.
Yeah.
And to do that, they assessed them using a test, the Clinical Dementia Rating Scale Sum of Boxes score.
Yeah.
Uh,
Not all
you
the boxes, just
you
some of the
you know
boxes.
everything about the test you need to.
Yeah.
Just
Essentially, a standardized, validated test to check our cognition in people who are suffering from dementia.
they also use several other scales. That's just my favorite.
Yep.
Um, So again, they're looking at a statistically significant and meaningful reduction of decline. So it's not
Yeah.
improving anything, it's preventing decline. And here's where another potential problem comes. Yes, it was statistically significant. However, we often see dementia occur in a stepwise decline. It's not you
Yeah.
hit this stage, then this stage, then this stage in a gradual expected progression. So, how are you really assessing that this is preventing a decline versus the disease was simply going to occur stepwise
Anyway.
anyway?
Yeah, yeah, exactly. So this is always a tough type of a question to ask. It does help that they, gathered a large number of people and enrolled them in here so that we could see as much of a difference as we possibly could. I don't know enough, Josh, in terms of talking about the difference in scores for these standardized tests to say that, oh, and this is the thing we always talk about, the paradox between what shows up as statistically significant and what's clinically meaningful, right? Like that's what we care about, what we actually see in our patients. But, the folks who were getting this antibody did get they continue to decline, but slower than the folks who were receiving the placebo in a fairly meaningful way in this case. Interestingly, Josh, there was secondary endpoints that they looked for, like the amount of amyloid, and they used PET scanning to take a look at that. The amyloid amount went way down for the folks on lecanemab, but this didn't correlate with the same sharp improvement in cognition. So thus showing you that, like, yeah, we're helping, but we're not really attacking the root of the problem.
So, yeah, the trial showed that leqembi removes amyloid plaques from the brain. It's given every 2 weeks via IV infusions. So, you have to go to an infusion center.
Hmm.
And it has been studied in people who have inherited forms of Alzheimer's by the dominantly inherited Alzheimer network, or DIAN.
Yep.
Uh, who have gene mutations that pretty much guarantee they'll develop Alzheimer's. So they're not just picking random people with dementia. These are folks who are coming from kind of a very dubious pool where, like, hey, just so you know, you're getting this disease. Want to let us study you? And
Yes.
these are folks who typically would develop it in their 30s, 40s, and 50s. Um,
Yeah, and
s-
it's a vulnerable population, right, Josh? These are folks who sometimes, them or their loved ones might be desperate for something. So you do have to be very open and honest about telling them what we're expecting and what to not expect. Otherwise, you could be harming these folks by, giving them false hopes and that. And so
so
all of this, yeah.
ultimately,
Sorry.
this did show, as you said, uh, a decline in memory, or it slowed declines in memory and thinking by about a third over the course of 18 months. So you get an extra year and a half of slightly more lucidity in people who already are early stage dementia when this may not be recognized. So I'd say about 15 to 20% of people have symptoms mild enough to be eligible for the drug,
Okay. Yes, that's true. Yeah.
which means we should probably talk about one or two of the more serious side effects. Um,
Yes, absolutely. Yes.
Small areas of the brain may get a little bit swollen, like if they're bruised, and that's from microhemorrhages, and that could be due to all the amyloid cleanup.
Yes.
Um, if it's not symptomatic, may not be a problem, and the brain bleeding or swelling will resolve on its own. However, if it is seen and you notice personality changes, which in somebody with dementia may be difficult to tell, it can prompt a hospital visit.
Right. And that's kind of a scary thing, right? You're saying that you can have declines in personality, behavior, all this kind of a thing because of the dementia itself. But the antibody that you're giving, while this amyloid is being cleared away, can actually cause damage essentially to parts of the brain, which can also cause these cognitive changes. And you have to see a specialist to try to figure out which is which, because you at that point may have to make a possible choice of stopping this medication.
Which brings up another great point, Santosh. This is going to cost about 26,000 a year. Now,
Oof.
Medicare has said it will cover 80% of the cost of the medication, which
Mhm.
sounds great, but determining who is eligible might require things like those PET scans, or if you suspect microhemorrhages, and those kinds of scans may not be covered by Medicare.
Right.
There's also follow up scans once treatment begins to make sure you're not developing things like bleeds, and
Mhm.
that the plaques aren't furthering, and that's not going to be covered. So that's going to be out of pocket costs as well.
Yeah. We just like we said before with these incremental changes, we want to be able to offer these kinds of treatments to as many people as possible if they're eligible and you know they can gain some benefit out of it. It would be heartbreaking to have a small hope like this and only offer it to people who can like monetarily afford it. That would be horrible.
So we are not at the end of the day saying do or don't take this drug, but there's some more accuracy to the claims it's making. Now, as long as we're over here sitting in pessimistic pharmacy corner,
Is that did we have to like renovate in order to make room for pessimistic pharmacy corner?
we had to do something with all these depressing drug boxes.
Okay. All right, fair.
Let's also talk about another one that I know we're late to the game to mention this, but
Yeah.
uh,
Okay.
Ozempic.
Okay. Yes.
And a bunch of people just kind of sat up and they're like, "Oh, Zempic, you say?
Yeah.
I've heard of this."
Yeah, absolutely. It's I'm here in Los Angeles and this medication semaglutide is supposed to be for treating diabetes. Okay, very important, and its efficacy is fantastic. But it was incidentally found, a lot like Viagra, had an interesting side effect. Semaglutide likewise had a very interesting side effect of weight loss. And when you're in Los Angeles and you have folks with lots of money who can, ask their doctor is like, hey, I know I don't have diabetes, but what about,
Are
nudge,
they
nudge, wink, wink.
are they asking their doctors though, or are they
I
telling them?
I hope that they're asking, and I hope that the physician is doing the right thing about properly considering all the risks and benefits before administering you know, a,
The original researchers who were looking into Ozempic in the 1970s were
mhm.
trying to study duodenal ulcers. Uh,
Oh, okay.
Diabetes at that time was just something, old people got. You couldn't do a lot about it. It wasn't
Yeah.
interesting, so to hell with them.
Yeah, and we're talking
And
we're talking about now type 2, right? So not the type that's genetic and or autoimmune where you knock out your own pancreatic cells, but the kind that you eat too much and you don't exercise enough and you also have a genetic predilection
and
and
this
yeah.
meant looking at the hormones that are secreted when people eat. So that's
Oh
how they
yeah.
found GLP-1
Oh, I
by
didn't even know that.
taking this peptide from pigs and pumping it through their pancreases, just to see what happened.
Okay. Not
And
into their own pancreases, into the other pig's pancreases.
yeah, sure.
Yeah. Okay.
So the real
Yeah.
turning point
Okay.
was when it was infused into people with type 2 diabetes and showed that blood glucose became completely normal in 4 hours by acting on both insulin and glucagon. Uh,
Cool. Okay.
it's nice because it's a weekly injection. That's instead of the daily injection that previously existed, Victoza or Saxenda.
Hmm.
Um, and it was developed to be a longer acting alternative to those. Now, it's not approved for weight loss. There is a version that's approved for weight loss, made by the same company, Novis Nordic Track something.
Novo Nordis.
Yes, them. And it's called Wegovy. Uh,
Yeah. What a great name. We go, V. Yeah,
So the reason it's injected weekly is that that's how long the half life is. So as long as it's
sure.
at a therapeutic concentration, and it's undergone step trials, semaglutide treatment effect in people with obesity, and that so it has been studied as weight loss, but most of the people taking it don't want to pay for the weight loss formulary and end up
R-
using Ozempic off label.
Yeah, exactly. And the issue here is the studies here were for people who have obesity that could be putting their lives at risk, right? So these aren't folks who are actually doing, probably Josh, most of these folks, doing pretty well with their weight actually and not sick, and just want to lose some weight with a miracle pill. That's that is a problem.
The
We
real
never studied that.
problem is we're lazy. All of us.
Yes, yeah, absolutely. If you give us a magic switch, we're gonna hit that.
So here's some of the problems. If you start taking Ozempic or Wegovy, your body will eventually get used to it. It will establish a new normal, and you'll get a weight plateau. Then you're stuck taking the drug forever to just have the same weight because if you
Hmm.
stop, all that weight will come back.
Yep.
Um, oh yeah, and Ozempic usually covered by health insurance because it's for diabetes, while Wegovy is not because it's not for diabetes. So again, there's a lot of reasons it's being used off label, which we do not endorse. Here's why people are talking about it. It can take several months to get to a therapeutic dose because it's injected very slowly to manage side effects, which are gastrointestinal in nature.
Yeah, but yeah, it's not as bad as that old what was that weight loss chip, the Olestra? You remember that caused anal leakage way back when? Our
Oh, great
older
phrase.
listeners may remember that. Yeah. But yeah, it doesn't make you feel good, and it shouldn't because it's messing with your hunger and satiety signals and all these kind of things. Yeah.
Now, the starting dose for someone with type 2 diabetes is 0.25 milligrams, a quarter of a milligram, once
Sure.
a week for 4 weeks, which is just meant to help your body get used to the medication. And then it's increased to half a milligram once a week until you hit your final dose. And over that time, over 30 weeks, people on it lose about 8 pounds.
Oh, okay. That's pretty significant.
And the maximum dose is 2 milligrams once a week. So that's a pretty big range from 0.25 to 2. Now, during a 40-week study, people receiving a 1 milligram Ozempic dose, so half the maximum, lost an average of 13 pounds.
Oh, wow. Okay.
So that's the diabetic one. So you take it, you're on this drug, you're committed to it for life to keep off the weight that you're losing, and you're really just trading weekly injections for a loss of about 8 pounds.
Yeah. And
8
by
to
the way,
13.
yeah, and by the way, the max 8 to 13, right? Just like you said, they're going to plateau there. It's not like exercise and proper, dietary changes which will continue to get you down to a healthy weight and then, you know, get you all the way there.
So if you are a celebrity who has to bulk up or slim down for a role that will last for a period of, weeks to months, yes, I can understand, again, not endorse, how frivolous use of this as a weight loss solution
Yeah.
would be appealing. If you're somebody who has put in the work and had things like a variety of medications and you have blood sugar under control and you're looking at this as an alternative to bariatric surgery, again, might be worth it. But if you're someone who's just, I just can't shake this last 10 pounds, probably not for you.
Right, because it's going to mess with your insides. You're going to feel like upset tummy and all these kind of things. There is a wonderful phenomenon, Josh, called Ozempic face because of how you lose weight. The buccal fat that you have right in your cheeks and everything makes you look a little, heroin cheek kind of thing. Um, but
Is that like
it's
is that like Malort face? Can you Google Ozempic face?
I hold on just a second. Ozempic face. Yeah. So what we got right here is I'm trying to find something where I can. I'm sorry. So you're losing your
I
weight and
mean, if
everything
you
looks like
search,
that.
folks, if you
Yeah.
go if you just do a simple Google search, it
Yeah.
comes right up on today.com.
Well,
Ozempic face, what it
essentially.
is and how to treat it. So it's common enough.
Right, right. So essentially, when we get older, the same thing happens. You lose collagen and elastin the same way that you lose fat. So you get this like dull, kind of sallow skin, and it happens over your face and everything, like over your cheeks. So that happens while you're taking Ozempic because you're getting rid of lipid in kind of a weird way.
And the Mayo Clinic would like you to stop using Ozempic face as it equates to cyberbullying.
Yeah, that's true. Also, on another note, honestly and truly, for those people using this frivolously, this is a terribly wonderful drug for people who have type 2 diabetes. Okay, and if you are using this frivolously, you're literally taking it away from people who need it. There's only so much drug that can be produced at one time safely, right? So just please, just stop it, okay? And leave it to doctors and patients who need it.
So let's just say you go with a low calorie diet. If you want quick weight loss, not necessarily maintained. With low calorie diets, you can have about a 12% decrease in weight in 8 weeks.
Yeah.
Um, Ozempic gets you to 15%, in some people up to 20% weight loss in a year. But again, a diet, you will plateau for a bit and then you'll keep going down. Ozempic, once you plateau, that's it. The drug has done everything it can.
Right. Exactly.
Uh,
And you
but
take it
here's the
longer.
really
Oh,
cool thing:
oh, sorry.
ignoring the
Yeah.
weight loss. Back to like diabetes.
Oh, yeah, absolutely. Sure, sure.
In the direct study from Scotland, not like, oh, here it is, fresh from Scotland.
Yeah.
No, the
it's called DIRCECT. Yeah.
yeah, the
Direct.
direct study where they managed to make people lose weight by dieting and lifestyle interventions. If you could lose 15% of your body weight, 86% of those people had diabetes remission.
Ooh, yeah, yeah. And we know this, right, Josh? Especially folks who are early in diabetes or pre-diabetic. We aggressively want them to lose weight because, every single pound of weight loss and getting healthy and this kind of thing reduces your chances of making the diabetes worse. So, yeah, it's a big deal.
So you can cure or put your own diabetes into remission by just losing 15% of your body weight. This doesn't mean instantly.
Right.
It just means that is the target if you want to have, better than Vegas odds of not having to deal with diabetes.
Mhm.
Um,
Yeah, yeah, absolutely.
it's like a way to make your body forget that it has diabetes, a inverse version. And as long as we're sucking things up instead of shooting them out, I don't know
Yeah.
what's the right metaphor. Santosh, it's your study.
This is not my study. And that was so weird. Why do I have to go after the weird segue? All
All
right.
right, so give your
Josh,
own set. You don't like my segue, you are welcome to take your own.
yeah, okay. Let's go from you know, fighting the fat and the diabetes all the way around to maybe restoring some fat. How about that, Josh? Because I'm going to talk about
We
multiple sclerosis.
we
Yeah.
just worked on getting rid of fat. Now you want to restore it?
Yeah, yeah. So I'm going to talk about a disease called multiple sclerosis as an example of what we're going to talk about. And in that, Josh, right, you have the insulation around your nerves that get knocked away, and those are mostly made of lipids. So, haha, segue complete. So over here we got Pritzker School of Molecular Engineering, and they were studying autoimmune diseases. Okay, so the plethora of diseases: type 1 diabetes, multiple sclerosis, all of these where you have your immune system that attacks part of your body because it's a confused and it thinks that the self, yourself, is actually a bad invader and it's trying to kill it, attack it. So these are progressive
Stop
skin.
attacking yourself. Stop
Yeah.
attacking yourself.
Exactly, exactly right. Only in this case, it's like one arm of your immune system holding the other arm of your immune system and punching you on the myelin sheath of your,
And it
you know,
turns out the
yeah,
solution to that are
yeah.
anti-vaxxers. No,
No,
an
no, no,
anti-vaccine.
no, no, no,
No, an inverse
and
vaccine.
in inverse, yeah, an inverse vaccine. Absolutely. So the investigator here published in Nature Biomedical Engineering. So we're going to talk to Dr. Professor Jeffrey Hubble and his team. What he said was, all right, we've got vaccines, right, Josh, where you take an antigen, which is something that your immune system recognizes, and you introduce it to your immune system. Hey, how you doing? And but you introduce it in a way where you're like, if you see this, kill it, like it's a wanted poster, right? So that's a vaccine. This one is an inverse vaccine. You introduce the same, a different antigen. So maybe in this case, a self antigen, and you introduce it in a nice way. And do you know how you do that, Josh?
With
With a little.
a Will Smith agent in a black suit holding a tiny little neuralizer.
No, 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 no. We'll get there in a bit. But first, you need a little molecule of sugar. Yeah. You need a little spoonful of sugar. So we're going to attach N-acetylgalactosamine or PGAL, a little sugar, onto the tagging molecule and send it in with a cell. Introduce it as an inverse vaccine, and the body goes, "Oh, wait! I've been attacking that antigen." And then it's then the neuralizer comes in, right? Then is a wait, I don't even remember
What
that
was I
antigen.
what was I just doing?
What was I just
An Egger suit, swamp gas? Okay. And off
all
it
gone?
goes, and you have now managed to teach your immune system to forget a
Yeah.
disease, which, okay, thriller writers, get to work.
It's so cool. So instead of teaching your immune system to attack something, you are removing some of the immune memory. Or actually, Josh, what's going on is you are resetting the immune memory, saying this is no longer a foreign antigen, this is a self antigen, and do not attack it. And we're very preclinical here, Josh. So the Nature paper that just recently came out on the 7th of September was a experiment only in our friendly neighborhood mice, but it worked really, really well. And these mice, which unfortunately genetically have a predilection for an autoimmune encephalitis, were treated with the inverse vaccine, and they had a lot less inflammation and destruction of their nerves.
And there's a lot of autoimmune conditions that this could potentially be incredibly helpful for, teaching the body to forget how to attack itself, which would be a non pill form, something you couldn't really develop resistance to. So, a lot of promise, very exciting. Maybe one day it'll get multiple sclerosis all the way down to just singular sclerosis.
Oh, we're aiming for zero sclerosis. Yeah. And as with everything else that we talked about today, Josh, incremental gains, but we'd love to see this technology start to make its way into clinical trials in humans, and fingers crossed that it's safe and that we can give it a try.
So that's it for this week. As always, we love to hear your comments, questions, and feedback. If you'd like to support us spiritually, emotionally, or financially, links to do that are in the show notes, along with links for further reading, including some of the studies we covered this week. Our theme music is composed by Rachel Leisure. You can find Santhosh and I on all the social medias. We're even on
Yay!
TikTok now, sometimes.
On occasion, yeah.
And you can sign up for our mailing list at travelmedicinepodcast.com. That
Woo!
has fun stuff about like when we're appearing live, which is always, if we're appearing dead somewhere, things have gone terribly wrong.
Yeah. Yeah, call the authorities and get us some help, because that's well, I don't know, Josh. We wouldn't be there, so it could be interesting, funny.
So if you want to find out if we are alive or dead, sign up for the mailing list.
there's there's got to be some other podcasters out there who using our wonderful listeners are sitting here going for that. Are they giving us like a subtle cry for help? Is that what's going on here?
The
Oh
branding is
God.
working. We've created interest. So until next time, as always, keep a song in your heart, soap on your hands, a shot in your arm, spin a globe when you've done all of those things, pick a country, and after you've done that, happy travels.
Bye everybody.